reactions presented by Punita Malhotra. We are going to study about the concept of oxidation number today. Oxidation number denotes the oxidation state of an element in a compound is certain according to a set of rules formulated on the basis that the electron pair in a covalent bond belongs entirely to more electronegative element. Now, what does this statement mean? Suppose you have a bond between hydrogen and fluorine. Since fluorine is more electronegative than hydrogen, so the covalent bond pair belongs entirely to fluorine. If the pair belongs to fluorine entirely, then it has an oxidation state of -1 and hydrogen has an oxidation state of +1. Let us look at another example. We have a bond between magnesium and oxygen. So oxygen is the more electronegative element here. This is not a covalent bond. So the complete electron transfer takes place, and we know that magnesium is a +2 charge and oxygen has a -2 charge. So the oxidation state of this ionic bond for oxygen is -2 and for magnesium is +2. Let us take another example of a covalent compound like water. In case of water, we have two oxygen hydrogen bonds. So we can rewrite this compound as HOH. In each of these cases, the electron pair belongs to the electronegative element oxygen. So electron pair of the oxygen hydrogen bond here belongs to oxygen. Therefore, -1 charge is there because of this particular electron pair, and the other electron pair between this oxygen and hydrogen belongs to the more electronegative oxygen atom, so another -1 charge. The total charge on oxygen in water becomes -2, so the oxidation number of oxygen in water is -2, and that each hydrogen is +1. Now, to remember which element is more electronegative than the other is slightly difficult. So there are a set of rules which are formulated to help in the finding of the oxidation numbers. We'll talk about the rules now. The rules for assigning oxidation numbers. The first rule is that in elements in the free or uncombined state, that means each atom bears an oxidation number of 0. What does this mean? So talk about any element: hydrogen, H2, oxygen, O2, sulfur, S8, phosphorus, P4, ozone, O3. In all these cases, the atom is present in its elemental form. It is in its uncombined state or in its free state. It is not forming any compound. It is present in the form of an element. So the oxidation number of hydrogen in H2 is equal to 0, of oxygen in O2 is equal to 0, of phosphorus in P4 is equal to 0, of sulfur in S8 is equal to 0, of oxygen in ozone is equal to 0, of carbon in C, diamond or graphite, or fullerene, C60. The carbon oxidation state is going to be 0. It is in its elemental state. That means uncombined. So that means whenever an element is not present in the, whenever an atom is present in the element form and not as a compound, then the oxidation state is 0. The second rule is that for ions composed of only one atom, the oxidation number is equal to the charge of the ion. What does this mean? Sodium ion Na plus has a charge equal to +1 because it is composed only of one atom. So the oxidation number is equal to the charge on the atom. Another example, aluminium ion is 3 plus. So the oxidation number of aluminium in this ion is going to be +3, since the charge on aluminium here is +3. Similarly, if I talk of oxide ion, that is O2 minus ion, the oxidation number of oxygen in oxide ion is going to be -2 because the ion has a charge of -2, and this is true for any ion which is composed of only one atom. The third rule states that oxidation number of fluorine is always -1 in its compound because fluorine is the most electronegative element. Fluorine is the most electronegative element known. Therefore, the oxidation number of fluorine is always -1 in its compound. It is 0 in its elemental state in F2. In F2, of course, because it is the elemental state, fluorine is going to be 0, while in case of any of its compounds, the oxidation state of fluorine is always -1. Coming to the next rule, oxidation number of oxygen is -2 in its compounds except peroxides like hydrogen peroxide and in superoxides like KO2, where in hydrogen peroxide the oxidation state is -1 and in superoxides it is -half. Peroxide means that the bond is of the kind of OOH. So whenever you have an oxygen single bond oxygen present, this is a peroxide bond, and each oxygen atom will have a -1 oxidation number in this case. What about compounds that oxygen forms with the fluorine, for example? So if oxygen forms a compound with fluorine, the oxidation number of oxygen in that particular compound, we have to find out the oxidation number of fluorine is always -1 irrespective of what compound it is or with which element it is forming the compound. So I'll take the example here. So if we have OF2, fluorine is always -1, or you can that since fluorine is more electronegative than oxygen, so the bond pair of the covalent bond between oxygen and fluorine is a part of fluorine only. For each fluorine has -1 charge, so oxygen will have a +2 charge in order the whole molecule is neutral. So fluorine, each of the fluorine is -1, therefore oxygen is +2 in this case. With fluorine, oxygen has positive oxidation state or oxidation number. Otherwise, oxidation number of oxygen is -2 in its compounds except peroxides where it is -1, and in case of superoxides where it is -half. Oxidation number of hydrogen is +1 except in hydrides. For example, take case of NaH, since hydrogen is more electronegative than sodium, so hydrogen takes the covalent bond pair towards itself, and hydrogen is case has a -1 charge, while sodium has a +1 charge or oxidation number. Therefore, the oxidation number of hydrogen in hydroxides is -1 because they are bridged to a electropositive element in this case. Oxidation number of the halogens, chlorine, bromine, and iodine is -1, except when they are bonded to fluorine or to oxygen, since fluorine and oxygen are more electronegative than these elements. And then in that case, chlorine, bromine, and iodine show a positive oxidation number. The oxidation number of group 1 elements is always 1. The 1 elements are lithium, sodium, potassium, rubidium, cesium. Francium we will not take because it is a radioactive element. Otherwise, that is also +1 oxidation state. And group 2 elements have oxidation state of +2. Group 2 elements are beryllium, magnesium, calcium, strontium, barium, and the electronegative element. So beryllium, magnesium, calcium, strontium, barium have oxidation state of +2. The last rule for signing oxidation numbers: the sum of oxidation numbers of all atoms in a compound must be equal to 0. So we have methane as a compound. So the oxidation number of carbon plus 4 atoms of hydrogen will come out to be 0. That means the sum of oxidation numbers of all the elements in a compound is equal to 0. The compound is neutral, therefore the sum of oxidation numbers is equal to 0. In case of polyatomic ions, the sum of all oxidation numbers is equal to charge on the ion. For example, phosphate ion, PO4 minus. So the oxidation number here of phosphorus plus 4 oxygen atoms is going to be equal to -3 because the charge on phosphate ion is equal to -3. So the oxidation number, the sum of oxidation numbers of phosphorus and 4 atoms of oxygen is going to be -3. So whatever is the charge on the polyatomic ion, the sum of oxidation of atoms is equally charged on the ion. We will look into some examples and try to find out oxidation numbers of some elements, atoms of some elements using these rules. What is the oxidation number of phosphorus in phosphate ion? Is a polyatomic ion, therefore sum of oxidation number of phosphorus plus 4 times the oxidation number of oxygen is going to be -3, where -3 is the charge on the ion. And we know that the oxidation number of oxygen is equal to -2 except in peroxides and superoxides. And this is not a peroxide or a superoxide. So the oxidation number of oxygen is taken as -2. If we solve for the oxidation number of phosphorus, it comes out to be -3 plus 8, which is equal to +5. So the oxidation number of phosphorus in phosphate ion is equal to +5. Calculate the oxidation number of sulfur in sodium sulfite. So the sum of oxidation number is going to be 0 since this is a compound which is neutral. The compound is neutral, and we know that the sum of oxidation numbers of the compound is equal to 0. this is equal to 0, and the oxidation number of group 1 elements is plus 1. Sodium is one element, so its oxidation number is plus 1. Sulfur, we have to find the oxidation number, plus 3 times the oxidation number of oxygen, which is minus 2, except in peroxides and superoxides, and the whole thing is going to be equal to 0. So the oxidation number of sulfur is equal to 0 plus 6 minus 2, which is equal to plus 4. So the oxidation number of sulfur in case of sodium sulfite comes out to be plus 4. What is the oxidation number of chromium atom in potassium dichromate? So let us look at the example. Potassium dichromate is again a compound. So the sum of oxidation number of all the atoms, that means potassium, 2 potassium plus 2 chromium plus 7 oxygen atoms, is going to be equal to 0, since it is a compound, it's neutral. Potassium is a group 1 element, so its oxidation number plus 1 plus 2 times chromium plus 7 into minus 2, which is the oxidation number of oxygen. This is equal to 0. So 2 chromium atoms have an oxidation number of 14 minus 2, which is equal to 12, and for each chromium the oxidation number is going to be plus 6. So the oxidation number of chromium in case of potassium dichromate is equal to plus 6. Calculate oxidation number of boron in Na2B4O7. So again, 2Na plus 4B plus 7O is equal to 0. The sum of oxidation numbers of all the atoms this compound is 0. Sodium is a group 1 element, so 2 plus 1 plus 4 times 1 plus 7 into minus 2, the oxidation number of oxygen. This is equal to 0. Therefore, 4 1 have oxidation number equal to 14 minus 2, which is equal to 12. Therefore, the oxidation number of boron is equal to 12 divided by 4, which is equal to 3. In nitrate ion, what is the oxidation number of nitrogen? So nitrate ion is made up of nitrogen plus 3 oxygen, and the charge on ion is equal to minus 1. Sum of the oxidation numbers is equal to minus. Therefore, nitrogen plus 3 into minus 2, which is the oxidation number of oxygen, is equal to minus 1. Oxidation number of nitrogen equal to minus 1 plus 6 equal to plus 5. The oxidation number of nitrogen in nitrate is equal to plus 5. And the oxidation number of nitrogen in ammonia is the last example I'm going to take. So nitrogen in ammonia, oxidation number, ammonia, nitrogen plus 3 hydrogen atoms. The sum of the oxidation numbers is equal to, since this is a compound, nitrogen plus 3 into 1 is equal to 0, since the number of hydrogen is plus 1. This is equal to -3, which is the oxidation number of nitrogen in this case. The oxidation number of nitrogen in ammonia is equal to -3. So, a particular element can have different oxidation numbers. If you see here only, nitrogen plus 5 minus 3. So, an element have different oxidation numbers. We will look at some more cases, some exceptional cases, but that try out more examples. So, ammonium ion, the oxidation number of nitrogen in ammonium ion, not hydrogen. We will find the oxidation number of nitrogen in ammonium ion. So we have nitrogen. So nitrogen plus 4 hydrogen atoms, and the charge on the ion is equal to plus 1. Each hydrogen atom has oxidation number of plus 1. So this becomes 4 equal to plus 1, or oxidation number of nitrogen is equal to -3. For manganate ion, oxidation number of manganese in that. So manganese plus 4 times the oxidation of oxygen is equal to the charge on the ion, which is -1. So Mn minus 8, as the oxidation number of each oxygen is minus 2 into minus 2 minus 8 is equal to minus 1. Therefore, manganese has oxidation number of plus 7 in MnO4 minus for manganate ion. H2SO4, the oxidation number of sulfur in H2SO4, we need to find that out. Oxidation number of sulfur H2SO4. So the oxidation number will be sum of oxidation number of 2 hydrogen atoms plus 1 sulfur and 2 hydrogens plus 1 sulfur plus 4 oxygen, and the sum of these is going to be 0. So 2 hydrogen, 1 sulfur, 4 oxygen, the sum of these is equal to 0, since this is a compound. Hydrogen oxidation number plus 1, so 2 into plus 1 is plus 2, plus sulfur, the atom which we will find out the oxygen number, plus 4 in minus 2 is minus 8, is equal to 0. So the oxidation number of sulfur equal to 6 in H2SO4. Oxidation number of sulfur in H2SO4 is equal to 6. Potassium has an oxidation number of plus 1. Need to find out the oxidation number of iron in this case, but you know the oxidation numbers of carbon and hydrogen. Know one thing for sure: the sum of oxidation numbers for polyatomic ions is equal to the charge on the ion. So cyanide ion, which is C minus, has a charge of -1. So the charge on this Cn minus is equal to -1. So I can use this rule that the sum of oxidation numbers of polyatomic ions is equal to the charge on ions. So 4 times the oxidation number of potassium plus the oxidation number of iron plus plus times the oxidation number of Cn minus. Cn minus is equal to 0 because this is a compound which is neutral. Compound of oxidation equal to 0. Potassium, we know the oxidation number plus 1. So, potassium is plus 4. Iron, we need to find the oxidation plus 6 into Cn minus. The oxidation number Cn minus is minus 1. So, this becomes minus 6. And the whole thing is equal to 0. So, the oxidation number of iron comes up to be plus 2. Oxidation number of iron in K4FeC6 would be plus 2. Oxidation number of carbon is 2H2. So here you have 2 carbon and 1 hydrogen. You have to find out the oxidation number of carbon. So oxidation number of 2 carbon atoms plus 2 hydrogen atoms. Carbon plus 2 atoms. The oxidation of 2 carbon plus 2 hydrogen is 0. C2 is made up of 2 carbon and 2 hydrogen. So that oxidation of hydrogen is equal to plus 1. So 2 times C plus 2 is equal to 0, as this is a compound. Therefore, carbon has oxidation number equal to minus 1. So, here are examples of how the oxidation number. We'll discuss some now. CO5. If we look at this compound and to find out the oxidation number, usuals that we've seen right now. So chromium 5 oxygen, which is 2, is equal to 0. This is a compound. So chromium will have an oxidation number plus 10, which is not possible. The oxidation number of plus 10 is not possible for chromium. So we will look at the structure of CrO5. If you have the structure of CrO5, you will see that it contains 2 cases where the oxygen bonded another oxygen atom. So this is one oxygen and this is the oxygen. Each of these will have an oxidation number of minus 1 since there is a peroxide bond here. So the oxidation number for both of these is going to be minus 1. At the oxygen this and this. The bond between the two is a peroxide bond. So oxygen and oxygen. This is a peroxide. This is a peroxide. Oxidation number of both these cases is equal to minus 1. Therefore, 4 of our oxygens have a oxidation number minus 1. Minus 1, minus 1, minus 1. So chromium plus 4 oxygen plus 1 oxygen. These are the different ways in which atoms are attached. The 4 oxygen atoms, as we just discussed, peroxide, so minus 1, minus 1, minus 1, and minus 1. So it makes it 4 to minus 1, plus 1 is the normal oxygen, which has a minus 2 oxidation number. This whole thing is equal to 0. Therefore, the oxidation number of comes out to be -4 minus 6, which on the other side plus 6. The addition number of here comes out to be plus 6. Let another example of a similar type where there is the peroxide bond, peroxide structure. So SOH minus. If we draw the structure of this compound, we see that there are two cases, oxygen 1 and oxygen. In these two oxygens, the oxidation rate of oxygen is going to be -1 because it is going -1 because it is bonded with the other oxygen atom single bond, like in a peroxide. So -1 and -1 is the oxygen number of both of these. The rest of the oxygen 3, 4, 5, 6 have oxidation number of -2. So 2 sulfur plus 2 oxygen plus 6 oxygen. 6 oxygen are different from 2 oxygen. 2 oxygen peroxide, yes, are normal oxygen. The sum of oxidation states is -2. So 2 sulfur -2 is each here is -1 plus 2 -2, which is the normal oxidation number of oxygen. This is equal to -2. You can say that 2s is equal to -2 plus 12 plus 2, and this is equal to 12. So sulfur has oxidation number of +6 in this. This is how we calculate the number of sulfur in S2OH2 minus, because the nature of S2OH2 minus oxidation. Two more examples. Fe3O4 iron. Find out the oxidation number. So if you use the normal method, this will be 3Fe plus 4O is equal to 0, and each iron will have oxidation number of 8 by 3 by 3. That's not the case. Fe4 is a mixed oxide. It is made up of FeO dot Fe2O3. So iron exists in two oxidation states here. In FeO, it exists as +2, and in Fe2O3, it exists as +3. So the oxidation numbers of iron in Fe3O4 are actually +2 and +3 because of FeO and Fe2O3. Ammonium nitrate. What is the oxidation number of nitrogen here? So if you calculate normally, 2N plus 4H plus 3O is equal to 0. So the oxidation number of 2 nitrogen is equal to okay, we'll just calculate here, plus 4 because each of the hydrogen is +1, and -6 since each oxygen is -2. So 2N is equal to +2 and N is equal to 1. But this is a special case again. You have ammonium ion and you have nitrate ion. So the oxidation number of nitrogen in ammonium ion we have to calculate, And then in case of nitrate ion, so in ammonium ion, which is NH4 plus, the charge on the ion is +1, so NH4 plus, nitrogen plus 4 hydrogen will give a charge equal to 1, and nitrogen will give, yeah, the sum of oxidation numbers is +1 because the charge on the ion is +1. So nitrogen will be 1 minus 4, which is equal to -3. So nitrogen oxidation number -3 in case of this particular nitrogen. Let us look at the other nitrogen. Let me mark it in green. So you have NO3. Actually, you have NO3 minus here. NO3 minus this whole part. NO3 minus, and we have to find out the oxidation number of nitrogen. Nitrogen plus 3 oxygen, the oxidation number sum is equal to -1, which is the charge on the ion. So nitrogen minus 6, because each oxygen is -2, is equal to -1. Therefore, nitrogen has an oxidation number of +5 in this case. So the green nitrogen +5, the red nitrogen -3. Nitrogen has two different oxidation numbers here. We'll just in the end discuss the paradox which is given in your NCERT textbook. So if you look at C3O2 and try to find out the oxidation number of carbon using the simple rules, it will come out to be 4/3. Br3O8, bromine will come out to be 16/3, and Na2S4O6, sulfur will come out to be 2.5. In these cases, these oxidation numbers, the fractional oxidation numbers, are actually the average oxidation states of the elements under examination. So if we look at their structures, so suppose we look at the structure of C3O2 carbon suboxide. Here the oxidation number of the central carbon is 0. Why? Because this carbon is attached to other carbon. Both are carbon atoms. None of these is more electronegative than the other. Therefore, the oxidation number on this carbon is 0, and this carbon is also 0 with respect to the carbon marked star. Similarly, on the other side, carbon-carbon, same electronegativity. So 0 is the oxidation number because the electron pair of this covalent bond remains shared between the two. It is not a part of any of the atoms because none of these is more electronegative than the other. So the central carbon has a 0 oxidation number. With respect to this carbon, this has a 0 oxidation number. Look at with respect to oxygen. So oxygen is more electronegative than carbon. So oxygen has an oxidation number of -2 here. If this is -2, this will be +2. Both the electrons of the double bond that belong to carbon also now are seen as a part of oxygen. So -2 is the oxidation state of this oxygen. So carbon is +2. Similarly here, oxygen, the shared pair is towards oxygen. So -2, and the carbon is +2. Look at the example of Br3O8 tribromo octa oxide ion. So here we have three bromines, but the placement, the way the three bromines are attached is slightly different. Now, bromine-bromine bond, both are equally electronegative, so there is no charge because of the similar electronegativity. Here also, the same case. This is attached to three oxygens, each minus 2, minus 2, minus 2. Sum of the negative charge minus 6, so this bromine is plus 6. The other bromine, minus 2, minus 2, minus 2 from the three oxygens, so this bromine also becomes plus 6. The central bromine, both are bromine-bromine, so none of these electron pairs is shifted towards any of the bromine. So this bromine will have the oxidation number only due to the two oxygens that are attached to it, because there lies the electronegativity difference. So minus 2, minus 2, minus 4. So this has to be plus 4, so that this part also becomes neutral. Similarly, the last example is that of tetrathionate ion S4O6 2 minus. Here, 4 sulfur atoms. So if we divide the molecule here, it divides into two. Sulfur-sulfur bond, same electronegativity of the two sulfurs, so 0 and 0 is the charge because of each of these. And sulfur-sulfur, again the electron pair is equally shared, so 0 and 0 is the oxidation number. Look at this sulfur, minus 2, minus 2, and minus 1 from here because the charge on this oxygen is minus 1, so plus 5. And similarly, this end also plus 5. These were some of the paradoxical fractional oxidation numbers, boxed information in your NCRT. Hopefully you've understood oxidation numbers, how to find out oxidation numbers. Thank you.